Good afternoon, Professor Yaverbaum. How are you?
Wow. Good. Thank you. How are you? That was good. Excuse me. That was very pleasant. Very good. Thank you. How are you? That's and good afternoon, Isabella. Hello.
Doing well, doing well.
That is good. That is good. That is, in fact, impressive. Anybody, anybody who's here right now, anybody who's saying that or saying anything is doing well automatically because you all achieved something by being here. And I'm not kidding about that. Okay, wait, I'm going to do my hellos, but thank you for the enthusiastic hello. And also, I'm sorry I'm late. You know, that's one thing about it's a very strange thing, this whole business of that we post these recordings, but now I always put the clock in. It's like really rattling. It makes it a lot harder for me to be late because then I see that I'm late in the recording. But anyway, hello, good afternoon, Isabella. Hello, Rachel. Hello, Amanda. Hello, Ardell. Hello, Aaliyah. Hello, Farina. Good afternoon, Miles. Hello, Melissa. Hello, Brian. Okay, awesome, awesome. I want to. All right. Okay. Yes, I am starting slightly late. Sorry. We'll oh, no, that's not what you want. Sorry. Hold on. Okay. Right. So, let me pull up one other thing too. Really, if you let me say again, and actually, I don't want to over dramatize to anybody, but if you're anything like, sorry. Okay. No, I will shut up for a second. Hold on. Okay. Okay. Right. All right. Number one. Oh, oh, sorry. Is there someone in the waiting room? I'm sorry. Okay, hang on. You're probably right. Hold on. Yes, there is. Sorry. Okay. Okay. Thank you for that. Sorry. And then who's? Yes. Thank you, Amanda. That was Amanda. Okay. So a couple things. One, I mean, this is a delicate thing to say, but having just checked, so if you're here right now, I believe I can say this is a dangerous thing to say, but I think if you're here right now, that means that you turned in your exam. I mean, I'm asserting, like having just looked, if you're right, okay, and and it's true that there's a couple of exams still outstanding and a couple of people who aren't here right now, who whatever, like, and maybe there's a thing or whatever, but if you're here, that means you handed in your exam and that means you definitely did, first of all, the right thing. And sometimes, we go through school, it's always easy to know what we did wrong. I just want to say, like, it should not go without noticing that at some point, I think for most of us, that exam, even if you thought it was a gift, or even if you thought, I mean, not a gift, but even if you thought like the rules were made it easier or something, there was probably a point in that exam where it was not a pleasant experience. I mean, certainly that would be true for me. Um, and even to show up then to class after that, especially thinking that you're now going to have to listen to an hour and 15 minutes more of physics, like I think that's an achievement. And I'm not kidding. And I'm saying this as someone who was a physics major and who then went to graduate school in physics. Like if I could hand in an exam and if I could sit through a class, like it's no joke. It's no joke. And so I just want to recognize that to all of you that, and again, many of you, maybe some of you found certain things in the exam by the end that were harder than you thought. Maybe you even think you made a mistake. Maybe that means you actually took it really seriously. And maybe you even see why, even though you were allowed to go on the web and talk to people, you still did something if you did that exam. You really did. If you did it with any integrity at all, and if you learned anything along the way, if you realize that certain things were hard and you get them now, even if you think you only get them because you wrote them down from copying them from other things, you know what you get now and you know what you don't. And I think for a lot of you, you now get some physics that you didn't get before. And I think that will be clear when I look at your exam. And I think that if you didn't do perfectly on the exam, a lot of you have a lot of other things going on, like homeworks and stuff, where it's going to work out fine. So anyway, I first of all just want to say it's something to even be here at all. Oh, cool. Oh, cool, cool. Thank you. Okay, great. And really, and that factors into my estimation of you as people and my like desire to write recommendations or help you with research later, whatever, but it also does help your grades here. Like it all is of a package. So that's number one. And of course, well, wait, number one, we will go over the exam when we get back from break, and you will get it back, unlike maybe certain documents that you didn't get back in certain semesters. And all of that. Blah, blah, blah. But if you noticed in Google Classroom that another homework assignment was just posted to be due when you get back from break, that might have annoyed you. I mean, I certainly hate the feeling of finally finishing something and then there's like no rest for the weary. But let me tell you that, in fact, that homework assignment that sorry, someone else is here. The homework assignment that, and can I also say, since I'm making a big deal of this, actually, I should make clear, actually, I'll let the person come in. The people, well, the few exams that are outstanding are of people who are literally here, not here right now at all, as in not even as in just came in late or something. I just want to make it clear again so that no one's ostracizing anybody else or do. Even the couple of people that walked in a couple of minutes later into the Zoom, just to be clear, I had their exams before they walked in. I'm saying that to everybody, just so you know. Even the people that walked in a couple of minutes now, they didn't just walk in with their exams. And I'm saying that again just because I think you should all get credit. Like, no funny business went on with that. What am I trying to say? Oh, but the homework assignment that I posted that is due when we get back, in fact, is number one, kind of a fun thing to do, and it does not involve math or equations. Number two is actually what we're going to do together this period, like in about a minute. We're going to, and I'm going to ask you to take it out and everything, but the homework assignment that I posted to be due when you get back from break is actually the activity that we're going to do today. We may not get through the whole sheet, but we'll get through most of it. And there's like no math in the sheet at all, for good or for bad. So then you could it'll take you 2 minutes to finish the sheet after this and totally turn it in for 50 points. You could turn it in today, you could turn it in when we get back from break when it's due. But basically what I'm saying is you should be able to do almost nothing during break about physics, except any catching up that you may believe that you need to do. So that, okay, we can okay. Sorry. Okay. So all that said, we're sorry. What am I saying? Oh, I'm saying that we're going to get rolling with physics in a minute or two, but the physics we're going to get rolling with is the sheet that you hopefully saw in Google Classroom. It's called homework 5. It's called, homework 4. It's called Unthingy Things. As the name will suggest, it's hopefully somewhat relaxing compared to what we sometimes do. It's what we're going to do in a minute. So please take it out if you see, or I should get confirmation. If someone could confirm that hopefully you see in your Google Classroom. Yeah. Okay. All right. Thank you. Okay. Yes. So we're going to do that in a minute. We're even going to take the risk of possibly involving breakout rooms, I say hesitantly. And therefore, unless there's like a crisis or something, or like someone like somehow, other than that, we're not going to talk about I'm done talking about the exam for today with what I just said. Like, we're going to put it to bed for right now and pick up this new activity, unless there's like some pressing crisis or something. Oh, yes. Okay, cool. Okay. So, I'm going to switch my screens. We're talking about, tell me if that worked. Did that work? Okay, so hopefully you have this in front of you, or you could find it. Like, this is the thing that a couple people just confirmed was in the stream. It looks like this. Right. So I'm not gonna read this out loud. But I'm gonna give you the basic summary of this, and then I'm gonna ask you all to do weird. Now I'm in stereo weirdness. Hold on. What can I do about that? That's really weird. Okay, so what's going on in this sheet? Oh, and this is meant like this sheet is actually important. We often in the past used to do it in the very first lab of this class or something like that. Like often we do it right at the beginning because it does set up some cool ideas that technically apply to the entire semester, but they apply very particularly to the chapter that we're about to start and that you've already started in lab. What I'm saying, but it's meant to be relaxing. So what I'm really trying to say is approach this sheet with a cleared mind. Don't try to overthink what physics significance it should or probably has or something like that. Just try to take it on its own terms. So what the sheet asks you to do is it asks you to get two objects from your desk. It asks you to clear your whole desk. You don't have to clear your whole desk. I mean, you're in your bedroom, for God's sake. What do I have to say about what's on your desk? But pick two objects from your desk, any two random objects, like say a pen and like an AirPod, or like a pen and a coffee cup or whatever. Just designate, and this is each one of you I'm talking to. Like we're going to do this. You're going to pick two objects from your desk as though we're about to do lab, and designate them in your mind, and now name them thing one and thing two in your mind. So that when we refer to thing one and thing two, you know what we're talking about. And I'm going to go one step further. And I'm going to say, from here on in, when I refer to thing one and thing two, I like whether it's your pen and your coffee cup or your cell phone and your AirPod, whatever thing one and thing two are for you, I'm going to make it a little bit more specific now. I'm going to say, if your pen is your thing number one, from here on in, when I say thing number one, what I'm actually going to ask you to focus on is not the entire pen, but focus on some point, some piece of the pen, somewhere at the center of it. Focus on a point or a piece of that pen that you think can reasonably represent the whole pen, if that makes sense. So we're going to pick a piece of the pen like toward the center, so that you're not really focusing anymore on the right side of the pen than you are on the left side of the pen, or something like that. And so then from here on in, when I ask you questions, when I say something like, oh, could your thing number one be over here? Well, what I really am asking is, could the center of your thing number one be over here? Like, and that's important to realize as we go through this sheet, because you'll find many questions would be very, very ambiguous if we don't have that idea in mind. Like if I ask you, is it possible for your pen to be on the corner of the desk? Like that's a confusing question, like depending on whether I mean one edge of the pen or the whole pen sticking out or what. So when I say thing one or thing two from now on, I'm going to ask you to picture the center point of thing one or thing two. Now I have to add one more constraint. I don't know if you want to write this down on the margins of the sheet or whatever, but I'm assuming you can read. I'm not reading out loud the sheet, and I'm going to give you time to sit with it. But the overview of the sheet is that you're asked to consider two objects, arbitrary, everyday, regular objects. Like, so you know, like a pen and a phone. You're going to call them thing one and thing two. You're going to note that whenever we refer to thing one and thing two, we really kind of mean the center point of each one of your objects. And lastly, I'm going to say that your objects are meant to be arbitrary. Like, it doesn't matter what they are. They could be a cell phone and a ruler, or they could be a cell phone and a pen. It doesn't matter, right? But that's an important qualification, because if I say it doesn't matter what your objects are, on the one end, I mean, you could pick whatever objects you want, sure, from your desk. And like whatever physics we come to conclude like should be true of whatever objects you pick. But on the other hand, that means I am assuming that we're talking about normal everyday objects. Like you can pick whatever objects you want from your desk, but I'm assuming that they are objects that sit on a desk. So we're not in this activity, even though it's meant to be like fun discussion, whatever, like it's not supposed to be a brain cruncher, but it is supposed to be a mind expander. We're sitting here today talking about whatever we can infer about physical, material, massive objects, such as pens or pencils or a piece of chalk. This is not supposed to be a secret quest to find out how much you secretly know about quantum mechanical electron orbitals or something. Like we're not talking about electrons here, or photons or something. Like every one of us may have read weird things about photons and electrons in either a chemistry class or a newspaper. Not the discussion for the moment. The discussion is regular everyday objects. Okay, that's number one. So arbitrary regular objects. But number two, now here's an important thing that actually came up in the other class. The flip side of arbitrary is when I say you pick two arbitrary objects from your desk, because we're going to try to figure out some things about arbitrary general objects. If I say you can pick whatever you want, it does mean you can pick whatever you want, but it also should mean that you are that whatever you learn should be reproducible or translatable to somebody else in the class who also picked whatever they wanted. And that's why we allowed everybody to pick whatever they want. We're just trying to study something about objects in general. So I just want to caution you, don't go, whatever these activities are that we're about to do, first of all, pick your objects in advance and then do the activities. Don't change your objects based on the activities. Based on the 5 things, okay? That's just a warning, because it'll confuse things. Second of all, you don't pick your objects just to be weird. We're going to try to have a discussion here, but there'll be enough to discuss. Don't go out of your way, in other words, to try to come up with objects that will deliberately show the whole point of the whole assignment to be false. Not because I can't take it. I'd actually sometimes people do that. People will try to construct things, so they'll try to anticipate where the discussion they assume is going, and then they try to be interesting and clever and controversial or something, and work things out so that they can show an exception to the rule that they figure is what the class discussion is going to be about. I totally admire, I have to give this speech in advance today because it happens every semester. I totally admire that instinct. I'm often that guy. I often regret it after being that guy, but in department meetings and stuff, I can be that guy who's just looking for a fight and looking for a clever way to have a fight, or just looking to show that things aren't as simple as everybody else wants to assume. I can totally sympathize with all that, but that shouldn't be our first goal. Our first goal today is going to be to try to figure, because often that means you're trying to fight with what you anticipate to be the goal of everybody else. And you might even be wrong from the get-go what that is. So you might even be double cycling yourself in that. So what I'm saying is we're all going to pick 2 arbitrary objects here. We're going to pick normal everyday objects from our desk. We're not going to go out of our way to come up with objects that might be weird in some special way. We might talk about them, but we're not going to pick them. We're going to pick 2 arbitrary objects, and then we're going to try, and I'll start you off because I know I'm talking a lot. I probably will put you in breakout rooms, even though some of us hate that. But we're going to look at the 5 tasks that are right here. I think I scrolled to them, they're centered on your screen. Those 5 lowercase Roman numerals. And maybe some of you have already raced through this in your mind as I'm talking. Fine. But what your goal is going to be for each one of these tasks, you're trying to evaluate whether it's actually reasonably possible to do with 2 regular everyday objects or impossible. And yes, we're doing this for discussion. So yes, there's going to be different interpretations that we're going to come in. But on the other hand, it is a physics class. I do have a concrete thing in mind ultimately. So to frame this discussion a little bit before it happens, I'll tell you in advance. I think definitively that some of these definitively are possible, at least by my definitions of these words or my understanding of these words. I think of these 5 tasks that I'm giving you, I think some definitively are possible and very easy to demonstrate, with 2 hands or something. And some of them are really not possible. You might find a way to squeeze out of it or something, but some of them, you have to try hard to come up with a way to make them possible. Whereas with others, you don't even have to try hard. They're just and that's the distinction I'm looking for. In the end, some of these you're going to say, not really possible. Maybe weirdly, but not really. And some of them you're going to be yeah, totally possible, totally easy. Let me show you. Duh. Okay. What I'm looking for is that, for each one, yes or no, or each one possible or impossible. If you think it's possible, you'd be able to show me with your 2, or you'd be able to say with your voice, well, take your hand and put it over here and then do this thing. And if you think something's impossible, you're going to explain why. But that's it. That's all. So I think this is one of these things that if you don't overthink it, if you underthink it and just play, then I think there's a lot of thinking that can come out. But if you overthink it from the start, it might just be confusing and annoying. And of course, that's what I always do. So it's these 5. Our job is to evaluate each one possible or impossible. Our job is not to try to worry about why we're doing it. We're doing it for fun and for free. If it's clear what we're about to do, I'm going to ask, can I ask for a show of electronic Oh, you can do share screen like this? I never knew that. Oh, do I have ADHD? No, not at all. Look at the butterfly. Okay. So Rachel understands. Okay, cool. Yeah, can I ask for a show of hands if you get what I'm basically asking you to do? It doesn't mean you know the
Yes.
yeah, okay, cool, cool. All right, thank you. That is very clear. Okay, so I'm gonna put you in breakout rooms. You're gonna do this. All of you could easily do this by yourself. Of course, you could get answers, but I'm gonna put you in breakout rooms. They're gonna be random. Some of you might start arguing, like don't hurt anybody's feelings. Nobody hit anybody physically, but feel free to hash out in the private room. You could try to figure out what you think I'm trying to get at with this, sure. But all right, here comes breakout rooms. But yes, I'm sure many of you have already gotten 5 answers already, and that's fine. Where is Oh, are you kidding me? Oh, okay, coming your way. Okay, and these are random. I apologize in advance if everybody hates everybody in their room. This is totally random. Okay. Oh, please join once you get. Cool. Cool. And so please do go to your break. Oh yeah, okay, you got it. You got it. Or Brian, you're good. Or Brian, you. Hello, Kimberly. Good afternoon, Eric. Good afternoon, Abby. Good afternoon. So, well, thank you very much. Yes, and I'll get your test back. Hopefully, have a great break. Don't do any work. Just or catch up. Have a great break. All right, bye. Great discussion. Bye. Oh, and I have to wait. Great.
Bye.
Bye. Bye. Have a great break. Yes, great. Great. Hello. 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 Good afternoon. But cannot do 3 or 5 is what I would call stuff, particles. But I maintain that there's a whole lot of things, and this is where the Justin thing does come in. Like things cannot do 3 or 5, but there are a whole lot of unthingy things. There are, and do not did it by number 3 or number 5. Such entities are, for, if you know that that's what a chord is, like, two notes at the same time of. So So independently, coincidentally, I actually do have to meet with Alyssa. With Alyssa and Justin about something entirely different. But yeah, Bo, are you? That was good. Are you?
Yeah, I'm here.
All good? Or
Yeah, I'm good.
okay. So that
Interesting,
was,
right?
I think, very interesting. Yeah.
Interesting, right?
I think very interesting. Yeah, very good. In your life, you know that's what a chord is like. Two notes at the same time. Of course, you can hear that. Of course, two notes can hear your ear at the same time. That's the difference between sound and noise, or something. Similarly, two electrical currents can be in the same place at the same time. Two colors of light can be in the same place. And also, furthermore, one sound is not in one place at one time. I can't even say where a sound is. Yet sound, heat, light fields, gravitational fields, all these things are real space and time that move measurably in space and time. Yet they arrive, and they, here's my last word, are actually the subject of this course. Is just to build some time, but aren't particles, such as wave pulses, electrical pulses. That's what this about. That's what the exciting aspect of physics, I think, is really about, is stuff that isn't stuff. Stuff that moves through space and time, but is not restricted by number 3 or number 5. Immaterial stuff. That's what the course is really about, but I know I'm totally over. I'm so sorry. Have a great break. I'm just going to go. So, but thank you very much. Yes, and I'll get your test back. Hopefully, have a great break. Don't do any work. Just or catch up. Have a great break. All right, bye. Great discussion. Bye. Oh, and I have to wait. Great.
Bye.
Bye. Bye. Have a great break. Yes, great. Great. Okay. Hello. Hey. Hello. I can always tell, when I hit that button that says breakout rooms were closed in 60 seconds, and when like 40% of the class comes right back instantaneously, that's generally a sign that you guys are done discussing. Maybe I've given you way too much time. Maybe it's been way too much time, but all right. But welcome back, everybody. Okay. I don't know if that was fun or not, but what, I would like to hear the results of these discussions. I would like to get my pen. Let's go to the next page. Yeah, I'm just as interested in whatever conclusions we've come to as any further. I would love to hear any report at any time of anything that anybody disagreed upon, like even if you resolved it in your room, like, oh, yes, okay. Like anything, oh, yes, Ardell, go for it, please.
Okay, so I was saying that I think that the first and the second instructions were possible, but the last three were impossible.
All right. Cool. Good.
overall.
That's a bold start. No, that's a strong. All right. So she's totally just addressed all of them in one fell swoop, which is awesome. And quick question, I forget, you were was there did everybody agree with you in the room, or was there disagreement in your room, or was there talk at all? And you can be honest, if there was no talk, there was no talk. That's fine too. But you're speaking for yourself or for the radio station, I guess is my question.
I'm speaking mostly for myself, but like my group agreed with 1 and 2 being possible.
Okay, interesting. All right. So there might have been some controversy on 3, 4, and 5. There's some agreement on 1 and 2, at least in Ardell's group. And I want to, good. All right. And I want to address each one of these individually. Does anybody else? Yeah, but this is cool. This is helpful. Like I'm learning, I just learned both what sort of possible final conclusion happened in her room, according to her, and some intermediary. I'd love to hear about any other room, like either conclusion or, oh, okay, Amanda, sorry. Agree. Oh, so Amanda. Oh, I see. Okay. Oh, so we're starting right. So so far, we have a little disagreement already between at least one member of the Ardell room and at least one member of the Amanda room on question 3 or on task 3. So good. Let's let the fur fly on 3. But it sounds like so far we're in agreement on 1 and 2. Any other? Is that true for the? So and honestly, my intention is to just go through them one at a time. So let's start with 1. 1, it seems like we have 2 vote. We have Ardell's room and Amanda's room both saying that 1 is possible. Is there anybody from any other room that either wants to disagree with that or possibly show me a quick like demonstration with their hand, or that would involve turning on video, I suppose. But is there anybody else who wants to weigh in on just number 1 we're talking? I think we have 2 votes so far for number 1 being possible. Like, I think that's what Ardell and Amanda are saying. Anybody else agree or disagree with number 1? Is that did Cynthia just say something? No. Farina, agreed. Okay, thank you. All right. Cool. And there's something else in the chat. Sorry. Oh, and Rachel, thank you. Okay. So that's 4 people, and I don't even know if Farina and Rachel were in the same room or not. I can't remember, but 4 people are saying number 1 is possible. So that there's no big. And 5, Lydia, thank you. Oh, and you weren't. Okay. So this is a lot. Thank you. I love it's just like magic that people actually hear what I'm saying. It's crazy. Especially because I can't see myself actually. Okay. Oh, and yes, and Cynthia's saying yes. Okay. So I will say, I'm not trying to keep anybody in suspense. Obviously, there's something about this ultimately that I do think is interesting. But going step by step, I'll say, first of all, it sounds like most people in the room are saying that number 1 is possible. Second of all, I'll say, I think that's quite reasonable. I agree with you. It's not meant to be a trick. It's meant to set up a contrast. And I'll even say, like, and I think this is what people are saying, if this is my thing 1, I'm trying to look how this looks like. Sorry, if this is thing 1, I can't, they're like fading into, but if this is thing 1, oh God, it's so weird. If this is thing 1 and this is thing 2, I agree with everybody that number 1 is possible because I can go, this thing is over here and this thing is over there, but both of these objects are occupying both of those spaces right now. Or I mean, right now, or maybe right now. Like maybe you get what I'm saying? Like, yeah, I agree with you all. You could have 2 objects, or more specifically, I can have the center of this pen, be at one point in space, while the center point of this stylus is at one different point in space. And both of these different points in space are being occupied by these different points of mass at one time. Not meant to be a trick. I agree, it's possible. So we can have, in effect, 2 points of mass at 2 points of space at one point in time. I agree. Now, number two, welcome to my bar mitzvah. Number 2, Ardell also said, and Amanda said, and everybody said, I think, there maybe is controversy on number 3, but now number 2, let's look at for a second, you guys are saying is also possible. And I agree, but I do agree. But I want to dwell on this one for a moment, if I can. I think this is what we're saying so far. Yeah, I think so far what we're saying is that task 1 and task 2 are both possible. In other words, they are two different questions that have the same answer, but I do want to dwell on them for a minute because that's what I do. But because I want to make sure that there's no confusion, just because two questions have the same answer doesn't mean that they're the same question, and certainly doesn't mean that you're getting the same information both times you get that answer. In other words, to do number 1, to show that it's possible, I do something like this with the weirdness of the camera. I don't know if these pens fade into nothingness for you the way they do for me, but I go like this for number 1. 2 points of mass, or two things, 2 points of space, 1 point in time. Here you go. Okay. Number 2, I do something more like this, maybe. Right? That was spazzy, but I think correct. Like I have 1 point of mass occupying 1 point of space, and then later, then I have a different point of mass occupying that same point in space, but at a different point in time. So now it's 2 things occupying 2 points in time, 1 point in space. Much more awkward thing to say, for sure, right? Like, and I would think possibly that a lot of people would have to give a lot more thought to unpack, like unscrambling the wording of number 2 and it's an unusual thing to ask, but I think I'm sorry. I know I'm agreeing with Ardell, with Amanda, with Cynthia, with I think everybody. If you're saying that number 2 is possible, I agree with you. But I do want to establish before we go on, in order to show that it's possible, you do have to do something different. You have to go something like or something like that, right? Just to say that that's a small suggestion right there. That time and space, they're very related. They're very related in that you can have 2 things at 1 point in space. They're very related in that you can have 2 points of mass at 2 points of space at 1 point in time. And you can also have 2 points of mass at 2 points in time at 1 point in space. Both of these things can be done with space and time, but we have to do something different to do each one. So that shows to me that there's something very similar about space and time, very related, but also somewhat different. Like you have to do something different to pull off these two. So it's not like a joke. So number 2 is not obviously possible to me, but I do think it's possible. But now we go to number 3. Oh, sorry. Okay, now, and I'm seeing some stuff happen in the chat, excuse me. But yes, let's discuss number 3 now. Everybody, you can put things in the private chat, as at least 2 people just did, and I'm going to look. Or you can put things in the public chat, or you can say things, but we're totally about number 3 now. And I'm saying right from the start, number 3 is usually where there is a little discussion or disagreement. Do I ultimately think there's something I want to say about it? Sure. But I don't think it's surprising at all that Ardell said one thing and Amanda said another, or whoever. There usually is some discussion about number 3. So let me just look. Oh, sorry. Okay. Hold on. One second. Pardon me. I'm just responding to some things in the chat. Definitely interesting things in the chat. Just give me a sec, and I'll decide what. Hold on. Oh.
Professor, I'm sorry to interrupt, but I just wanted to say I take back what I said earlier. I read it wrong, and I don't think it is possible.
Oh, interesting.
Yeah, but I do think it would be possible if they could be on top of each other.
Oh, okay. Very interesting. Hold on. I totally want to address this. And you're talking about number 3, I think, yes?
Yeah.
Okay, great. Perfect. Hold on a second. That's great. That's actually, I totally hear you, and I'm going to address, and you're totally welcome. Yes, that I appreciate that you're correct, updating what you earlier said. I totally noted. So there's a lot of interesting things happening in the chat here. Wait. Oh my God, this is so, okay, wait, now I've actually gotten like, oh wait, all right, sorry, I have to keep it coming if you, so I'm just reading the chat, and I think the chat is particularly, a lot of you are saying very interesting things in the chat, and they don't need, so give me a second, sorry, okay. Oh. Okay. Right. Oh, right. Wow. Okay. Okay, wait. So there's a lot of interesting things happening in the chat, and I think if I like to generally individually respond to each thing in the chat, especially if it's private. I like to individually respond. Right now, I'm going to beg all of your forgiveness. I'm not going to individually type because I'm going to fall behind, but I am reading every single one of them, and I'm going to and I'm even reading like the corrections and takebacks, which are interesting. Okay. All right. If you trust me that I just read everything in the chat. Again, I'm going to try to address what's happening in the chat like publicly now. Please know that I know which one of you said what and stuff like that. And you're all saying really interesting things. Let me also say, I like these takebacks in a way. They happen in the other class too. As a matter of fact, almost very similar. Like at least 2 people now have either publicly just like one person just publicly took something back. And then a couple of people in the private chat are saying things like, oh, my bad when I said originally this, like I was thinking that. I want to quickly say to all of you, especially when we're having discussions like this and stuff in a physics class, I think it's terrific, those of you who can do that. Any one of you who can say, oh, I thought one thing, but now that was wrong, I see another. It's totally terrific that you have no problem admitting like, imperfection and growth and all that. And it actually does help the discussion too, because you're right. Some of you might suspect that sometimes if one of you says something that's like wrong but clever, I might spend a lot of time on it because I want to honor your brain, and because it's very interesting. But sometimes I will spend a long time talking about things that people say that maybe they don't even believe anymore. So I could see why you'd want to snatch those things back and let me know like where the class actually is. Excellent. Let me also tell you all that when you're snatching these things back, I hope it's not because you're afraid that I will think, oh my God, that person totally said the wrong thing. Like am I judging? Of course I'm judging, but I'm judging much more like how much people are talking, what they're not whether they're saying right or wrong things, really. I mean, so don't worry about that. But anyway, so I'll cut straight to the chase here on number 3. I've gotten so much in the chat. I'm confident you all are paying attention to number 3 and thinking about it honestly. Oh, and some people are even possibly volunteering to show things, but then I don't know if they want to do their video or not. I'm going to hold off on that for a minute and just say, number 3. Wait, what do I want to say? Hang on. Number 3 is always what sparks the most controversy every semester. And partly because it does raise the most questions about what am I really looking for in this whole thing? Like really how are we supposed to be interpreting my question? It usually comes to kind of a head in number 3. So, so I'll say this about number 3. First of all, yes, number 3 seems to tap into some memories that many of you have of chemistry or quantum or chemistry, or if you've taken PChem, or general discussion of orbitals, electron orbitals, and things like that. Question 3 can start tapping into some of these larger issues, or Schrodinger's cat or something. Let me start by saying, of course, I love physics. I'd love to talk about physics to any level, to, wherever physics is doing in the year 2021, or the year 1905, or the year 1626 AD. But right now, I can only assume that it's not fair for me to assume that anybody in this class has like done quantum physics. And it's not even really fair for me to assume that anything you learned in chemistry about quantum physics is fair game here. Like, I'm not saying you don't know it and don't use it, but something about this question is meant to be about arbitrary objects in the macroscopic everyday world. I am going to relate this back to chemistry and quantum physics and stuff like that. I am. Like, no one's crazy to bring those things up. But what I'm actually trying to show right now is what the regular world kind of is like. And then perhaps in contrast to that, what might be interesting about the microscopic world. But right now, okay. So right now, first of all, those of you who are asking, am I including like quantum mechanics in my question of number 3? Like, for the moment, no. I'm just really talking about regular macroscopic arbitrary objects that you can feel, touch, and see on your desk. Like, I'm not actually talking about individual electrons right now. I don't know about them because I can't relate to them right now. That's number 1. So whatever I'm asking about number 3 is like, what can you do with these regular objects? Now, still, even with regular objects, there's some good questions being raised in the chat, publicly and privately, about, okay, well, if we've got 2 regular objects, like, does it count if I put one on top of the other, for example? Is that 2 objects being in the same place at the same time? Like, they are in the same, if I put one object on top of the other, what's really good about that idea that I think 2 people put in the chat, and certainly people put every semester, something like this, it's valid. I don't know if it's right, but it's valid. Like, people will say, well, if I put one pen on top of the other, then the centers of them are definitely both on the same like X coordinate of my desk, so to speak. They're just like in different Z coordinates. So does that count, Yaverbaum? And I want to say that's very clever and gets into something, certainly shows an understanding of vectors and dimensionality and all that. But I would say that's clever, but doesn't count. I mean, that would not count as 2 things being at the same place at the same time. I think, in other words, if we're going to go by my definition of center here, I want the centers of both objects, assuming there is, I want the center point. Oh, and if that's a question, I'll get it 1 second. I'm sorry. But I want the center points of both these objects to be not just at the same X coordinate or Y coordinate, but at X, Y, and Z coordinates. Like, I want the centers of both objects to be at the same point in space, at the same point in time. So I would say, all right, oh, cool. Okay. So, right. So if we put them on top, like the clever start of trying to get around this, but I don't think it actually fulfills the dream. I'll go a step. So far I'm thinking.
It's like, I'm sorry, Professor, but it's like if you put it in a sense of when you're like really close to someone and you're talking about personal space, but you're not like, you're in the same place, but you have your own space and that object has its own space.
That is true. Okay. That is, sorry, I'm smiling because that is very, very, like, the issue of personal space. I'm smiling because that's very real. I think the issue of, and I mean, some of us might forget sometimes with all these Zoom classes, but oh yes, no, let me take a moment to acknowledge the idea of personal space is very, very real. I'm personally very sensitive to it for sure. Like, sometimes I want mine invaded and sometimes I don't. And yes, you are right that when it comes to personal space, which might even matter more than any other kind of space, it's true that a person can be starting to get near another person and start even to play with that boundary, but I forget which way you're saying this, but it's totally true that with people, there's a way in which I can be in your space in all the bad senses of the word.
I'm sorry, but no matter how close you get to that person or how you're not in the same space. Because you're like for the object, for instance, it'll be in one space, but the other object, no matter how close it gets, it's still in its own place.
Oh, okay. Yes, I think that that's right. When it comes to fit, I wasn't sure if that's what yes, right. Even if, in other words, even if I feel that another human being is getting too close for comfort, they are not actually occupying the same space as me. Right, I agree. And because to really do that, at least by our definitions here, we really mean like if we were instead of two human beings, if we were two marbles, we really mean like, can the center of one marble actually be at the same point of time of space as the center point of the other marble at the same time? And right, I agree with you that number one, human beings I don't think can do this, and I don't think marbles can do it. I don't think stuff on our desk can do it. Like I'm leaning towards, and I'm watching the clock too, I'm verging on saying, you know, when it comes to objects, like we can do task number one and task number two, but task number three now asks us to do something not possible. Like we are being asked in number three to have 2 points of mass, or two thing points at one space point at one time point. And many of you who are, let me put it, almost all of you who brought up anything from chemistry or electrons or quantum mechanics or Pauli exclusion principle, and I will totally address that. I think it's great. Any of you who brought up Pauli exclusion principle, yes, I'm totally going to address that. But if you're bringing up all those things, kind of the reason is that we all, I think, intuitively know that if we're going to try to shove two things at the same space at the same time, we're going to have to start thinking wacky and think like electrons or something, because I think what we're all agreeing, I think, or with one exception, I think we're all agreeing that with regular everyday objects, before Professor Sheehan gets involved or Professor Pauli or whatever, with regular objects, they like bang off each other and they don't share a space. There just ain't no sharing space. I don't even need to talk about an orbital or something. They just don't share a space, regular objects. In other words, again, I'm going to get back to the chemistry in a second, but macroscopic, material, palpable, tangible objects definitely seem to obey what we call the Pauli exclusion. Like they definitely don't want to share space. But that doesn't mean we're done. But that's what I'm saying so far. But on number three, there's still a healthy, happy controversy around number three. Like some of you might have changed your answer on number three because it's hard to read correctly the first time. Like you might have misread it and thought it was number two or something. That's all fine. But the other reason some of you might feel conflicted on number three, and some of you did put some of this stuff in the chat, is like, okay, even if we can't put one object on top of the other, I mean, we can, but I'm saying that wouldn't count. What some of you bring up are different versions of like, could we put one object in the other? Like, what if one object is like a cup and I put a pencil in it? Like, well, yeah, like some of you might be thinking, I want to address this. If you didn't think it, it's fine. But if you are thinking it, it's worth addressing, which is, wait, can I put like, what if my two objects are like a cup and a pen, or like a cup and an ice cube or something? Can, if you're all hung up, Yaverbaum, like, Yaverbaum, you're all hung up on these arbitrary regular objects on the desk, but you're also hung up on, you keep saying the center, Yaverbaum, and you put it in the instructions. So like if I'm supposed to take you literally or seriously, Yaverbaum, you fiend, you, then can't I call object number one a cup and object number two a pen? And can't I put the center of the pen in the center? And this is not an argument. I'm just saying this might be on some of your minds, or something like this was on some of your minds when you wrote in the chat. What about putting the pen, the center of the pen, in the center of the cup? Then like, hey, does that do it? Or someone in the other class said, what about a boomerang? Like, can't you put like a pencil like in the center of the boomer, not the center, but like that space? Or put one last final way, you might ask, what about like I go to Dunkin' Donuts and I buy a whole box of Munchkins. Oh, now I'm going to make everybody hungry. So sorry, I'm hungry. But what if I buy Munchkins and I buy donuts? Can I like take a Munchkin, the donut holes, in other words, I'm talking about. I don't want to mention a brand name. But if you take a donut hole and then like put it in the hole of a donut, you might ask, well, have we done it? Is that what you want? Yeah, like, isn't that the center of 2 points being, isn't that the centers of two objects being at the same point in space, the same point in time? And the reason I want to address all this, first of all, that all this is a long way to say, if you have to think about number three at all, or if you had a debate or anything, you're not crazy. There is something going on with number three. But I would say the most I think three is impossible. That's what I'm going to say. Okay, I'm going to flip the page a second. I think there's a lot of good debate we can have about number 3 and a lot of things, ways we can look at it. But I think the answer to number 3 is impossible, which I think also agrees with what most people were telling me before. But if we're interpreting things on a macroscopic level, I think the answer to number 3 is impossible. And here's kind of why. Yeah, is that I want to accept, I'm pretty sure that some people in the room are worried about this, because they usually are, and it's a smart thing to be worried about. If you're worried about this, like donut hole in a donut or ice cube in a coffee cup or whatever, you have good reason to be worried about that, because I went to pains in this sheet to tell you regular everyday objects, but I also went to pains to say the center point. So that apparently these things are important. So you're right to not, so if you're not sure how to assign the importance, what I'm saying is this: we want to pick any 2 objects off our desk that are arbitrary, that don't have any special properties, right? It's true. I could go out of my way to design. I could say, oh, I'm going to cleverly take a cup, which is hollowed out on the inside. In other words, I'm going to cleverly take an object for which the center of it doesn't actually have any stuff there. Like, that's interesting. Like, that's actually a concept. Like, some objects in the world, their very center is not filled by the object at all. They are often called containers, right? But they don't have to be. They can also be a 2-dimensional object, like a boomerang. Like, there's no stuff in what is actually the center of the boomerang, or there's no stuff in the center. There's no cup in the center of a cup. There's space for a beverage, right? So we can pull this off if we cleverly and purposely, if we deliberately pick an object off our desk that has the special property of having an empty center of mass. If we pick up such an object, we can shove the other object in it, and we can say to ourselves, kind of looks like 2 objects are occupying the same space at the same time. But I bring this whole exception up kind of to show the rule, to prove that it's actually a falsehood. Like, if we went to that trouble to do that, number 1, we wouldn't be picking an arbitrary object. We would be deliberately picking an object that has sort of special properties that might not be on your desk in the other side of the room. And number 2, we'd be doing that because we realize way in the back of our mind somehow that the only way we're going to get a pen to occupy the same spot as a cup is if indeed we hollow out that cup and put the pen where there's no cup stuff. Meaning that even that example, which is terrific. I mean, like, some people brought up in the chat, and it's a terrific example. But even that example kind of ultimately shows what's really going on here, which is that once you acknowledge stuff, thingy stuff, material, particular, massive, tangible, palpable matter, once you have like matter, if you want to call it that, then you can't have 2 of it at the same place at the same time. The only way you can have 2 things at the same place at the same time, it seems, is if one of those things really isn't a thing at that point, right? That's what we're really, and again, I'm not saying, doesn't that blow your mind? I don't think this blows anybody's mind. I'm just trying to sort of be as clear as I can, or as like fine-tuning as I can about so far what I think. So I think you can make number 3 possible under special conditions. You can make number 3 possible if you go to the trouble of picking a certain kind of object, the kind of object that actually shows in the end, when you really think about it, that really what I'm saying is, and I'm partly, at the risk of cutting off discussion thing, I'm saying in the way that I'm trying to interpret this assignment, I'm saying task 3 is impossible, or put one. And also, by the way, I'm still not trying to dismiss anything about quantum physics or chemistry that anybody said in the chat. I still do want to get back to that. It might, looking at the time, it might be next week when I do. But a last way to say that this is impossible. Oh, and I've been thinking we have 4:30. We have till 4:20. I know we have 2 minutes, so I'm going to wrap this up really fast. But I say task 3 is impossible. Okay. Meaning, once again, you can't do it unless you by the definitions that you use in task 1 and task 2, you really have to kind of swap horses midstream to make task 3 possible. If we're going to, but now to quickly, since we have like a minute and a half, I'm going to cut to the chase and say, I also think by these definitions that number 4 is possible, but number 5 is impossible. I'm saying that fast now because we have 1 more minute, but I think task number 5 is also impossible. Yes, and if you don't like impossible, you can call 3 and 5 both restrictions or constraints. And again, now, what's the point of this whole exercise? And There is a little bit more of it to do to answer questions, but if you want to get full 50 points for the homework, but there's whatever you write for your answers for the remaining questions, like what do you think a particle is? What do you think? It's whatever you think. Okay, so don't stress it. But I'll tell you here really quickly what I think the answer is. What I think is going on here is we just realized something, we demonstrated something obvious to us. We all kind of know in one part of our brain, stuff cannot, we all know in one part of our brain that you can't have two things be in one space at one time. We also kind of know in our brain that one thing cannot be in two spaces at one time, even though one thing can be at two times at one space, which is very weird. That's number 4. We'll get back to that. But number 4 is possible. And it's just a rearrangement of words. But number 5 is not. Objects cannot be in two places at the same time, and two objects cannot be at one place at one time. But who cares? How did you not know this before? Of course you knew this before. Here's what I'm telling you. What I think you didn't know before is the things that cannot do, number 3 or number 5, the things that cannot do, number 3 and number 5, is not everything in the world. And it's not even everything in physics. It's just everything that we would ever call a particle. And this is the answer to the rest of the homework. A particle is a thing. I know it's 4:20. Let me just say this as clearly as I can and we'll go, but we'll pick up on this. But I think this is important. If you can hang for 1 minute, please do. If you can't, go. But a particle doesn't have to mean something really small. It could mean a planet. A particle is anything that is thingy, anything that is material, tangible, palpable, solid in the specific respect of it can't do number 3 or it can't do number 5. Like nothing can do number 3 or number 5, meaning no material actual object, no physical particle like on your desk can be at two places at once or share a place at once with another thing. But here's why I'm making a big deal about this. Not to go crazy with quantum or anything like that. What I'm here to say is, and I'll say it very quickly, but I know it's 4:20. Maybe you can write this, maybe not, but I'm saying things that exist in space and time that cannot do 3 or 5 are called particles. There's tons of things that exist in space and time and move through space and time in measurable, predictable ways. Hear me now. There are tons of things that live in and move through space and time in measurable, predictable ways, i.e., tons of things in physics, tons of scientific real things that do disobey 3 and 5. There are tons of things in the world that are not restricted by 3 and 5, and yet they're real. What are those things? Those things are things like sound, heat, electricity, electric current, electric field, magnetic current, light, did I say sound? Water waves, energy flow, anything like this, which is actually the subject of this course, right? You just started it in lab with the waves. That's where we're going next. I'm about to go. I see the time. I'm sorry to keep you, but what I'm saying is what this course is really about is waves, fields, and radiation. 3 things that totally exist in science, that totally move from space to space in time in measurable ways, but you can have 2 sounds at the same place at the same time. It's called an interruption, right? If someone else were to talk right now to say, Yaverbaum, class is over, please, we gotta go. You would hear me talking while you heard that person talking. You would hear 2 sounds exist in your ear at the same time. No joke, no exaggeration. That means sound is not a thing you think. Sound is not a particle. It exists, it's real, but it's not a thing in the sense of 3 and 5. Everything we study for the rest of this course is like that. Everything we study for the rest of this course exists in space and time in a measurable way, but can share spaces and times with other like things, or can be spread out in space and time, like sound waves, heat waves, electrical waves, light waves. That's what we're doing in the course for the rest. That's what the point of the course is, but I'm sorry I've kept you late. Please have a very great break. Please go. Please go. Thank you. Thank you. No, have a great break. Goodbye. You are good people. I love you all in a very mellow, innocent way. But goodbye. And I'll post everything. And good job. And goodbye. Have a good break. Yes, thank you. Have a good break. Have a great break. Thank you. Thank you. Have a great. Take care. Yes, awesome. Take care. Thank you. Oh, and we'll get back to the Pauli exclusion principle. I promise we will. We will. Great. Thank you. Thank you. Yes, enjoy your break. Good. I will post everything. I promise. I will. Okay. Bye. I think I'm saying bye. Yes. Bye. All good. Bye.